It has been several months since one of humanity's most accomplished spacecraft, the Voyager 1 probe, stopped talking to us. And though they remain somewhat hopeful, Voyager mission scientists are preparing for the worst, a goodbye. As Bruce Wagner, the Voyager mission assurance manager, said, sad and frustrated to have the spacecraft still working but muted. Bruce Wagner, the Voyager mission assurance manager, even though we know the end could come at any time, it's never easy to lose a spacecraft, especially one like Voyager 1. For more than 45 years, this boxy machine with a pearly white conical disc that sort of makes it look like a giant loudspeaker in space has been sending back stunning data. And I mean stunning. Not only is it the farthest human-made object ever, but it's also responsible for the identification of new Jovian moons, the discovery of yet another Saturnian ring, and the solar system's first and only family portrait that includes our eclectic gang of planets. It's also why we have the powerful pale blue dot image that resurfaces on the internet every so often to remind us of our insignificance, or rather, significance, depending on your perspective. As Carl Sagan famously said, "Look again at that dot. That's here. That's home. That's us. On it, everyone you love, everyone you know, everyone you ever heard of, every human being who ever was, has lived out their lives." The image of the Earth from a cosmic perspective, just a mere mote of dust suspended in a moonbeam, became nearly as memorable as the Earthrise photo taken by an Apollo 8 astronaut showing the planet as seen from the moon. The probe, which runs on nuclear-powered systems called radioisotope thermoelectric generators, kept flying. Our solar system has no clear boundary, but in the 2000s it crossed the termination shock, where solar wind particles abruptly slow below the speed of sound due to pressure from the gas and magnetic fields in interstellar space. Then, in the 2010s, it breached the heliopause, the boundary between the solar wind and the interstellar wind. With 4 instruments operating on Voyager 1, it now has a new job, measuring the magnetic field strength, the density of the plasma, and the energy and direction of charged particles in the environment they're traveling through. The purpose of the interstellar mission is to measure the sun's effects as we go further and further from Earth. We're trying to find out how the sun's heliosphere interacts with interstellar space, says Suzanne Dodd, project manager of the Voyager interstellar mission at NASA Jet Propulsion Laboratory. Voyager 1 is currently 15 billion miles from home, but for perspective, the nearest star is some 25 trillion miles away. It's a remarkable coda for its mission, decades after the probes completed their main goals. But the spacecraft has always had a secondary task, conveying a message to any aliens from beyond the solar system who might one day peek inside a craft. Both Voyager 1 and its twin, Voyager 2, carry a golden record, which looks like vinyl but is made of metal. A team of scientists and artists, including Sagan and Frank Drake, packed music, nature sounds, messages, photos, and more on each record. And they included players and instructions, should anyone find them. The ambitious project seeks to tell a story about humanity, what humans aspire to, and our world. It includes the music of Bach and Chuck Berry and images of families, homes, and scientific advances. According to John Lomberg, a scientific artist and the designer for the Golden Records team, the purpose of the record was to try to answer questions that we would have. What were the beings like who sent it? What do they look like? What do they act like? What was their world like? So it's really a self-portrait. Unlike the search for extraterrestrial intelligence, or SETI, the records are not designed to be a prelude to first contact. In fact, the Golden Records might be found millions of years from now, perhaps when human civilizations no longer exist. It's more like finding a fossil. You can't talk to the dinosaurs. This is a relic, our obituary in a way, the memento that we were once here. The Voyager probes were preceded by the Pioneer missions, which carried small metal plaques with symbolic messages. The pair of pioneers left the solar system in the 1980s and 90s, but they're no longer functioning. Since then, no space mission has incorporated a similar record of humanity. Some say NASA's New Horizons, which flew by Pluto in 2015, offered another chance. However, that mission, as Lomberg says, was a missed opportunity, although it might still be possible to send a digital message to the spacecraft's computer. That would be durable, but it would not last as long as the golden records. The Voyagers have had a tangible influence on space exploration ever since. Their success inspired NASA and other agencies to revisit the outer planets, especially Jupiter and Saturn, and their myriad moons. These subsequent missions include Galileo, Juno, Cassini, and the European Space Agency's Huygens lander, plus new probes in the works, such as the Europa Clipper, Dragonfly, ESA's JUICE, and potential voyages to Uranus and Saturn's moon Enceladus. The Voyagers influenced pop culture, too. The first Star Trek movie in 1979 included an alien spacecraft called Voyager, which was actually an altered fictional Voyager 6. Voyager and the Golden Records have turned up in TV shows like Saturday Night Live, The West Wing, and, of course, The X-Files. The composer Dario Marianelli even wrote a Voyager-inspired violin concerto. The pair of spacecraft have lasted far longer than anyone imagined, and, Dodd says, the instruments are working and the data is still great. But they're showing signs of age. All this time, Voyager 1's cosmic letters have come through as computer messages often do, with zeros and ones in precise patterns. Through a little bit of handiwork, such sequences can be translated into words the human mind can grasp, and scientists were always excited to open a new package of Voyager 1's binary code. But then, in September of last year, the zeros and ones stopped making sense. The engineering team said that the call between the spacecraft and the Earth was still connected, but Voyager's voice was replaced with a monotonous dial tone. Glitches have happened to Voyager 1 before, such as in 2022 when the probe's attitude articulation and control system exhibited some complications, but this one seems to be a doozy. The team still hasn't been able to fix it up, even months since the issue revealed itself, and is actually still searching for the crux of the problem. So, is it time to call the final curtain on Voyager 1? Well, to that end, scientists aren't quite sure yet. They remain working to remedy the situation, and quite diligently at that. Voyager mission engineer Karim Badaruddin revealed in a recent statement that the team is tired because we have sustained a brisk pace for 3 months now, but we press on because we have ideas and we have hope. In December of 2023, the Voyager 1 team announced that the spacecraft's malfunction lies with its flight data system, which is one of its onboard computers. There used to be a backup flight data system, but that stopped working in 1981. Because of this issue, scientists are not receiving any science data or updates about the probe's health and status, including information that might reveal the source of the problem. Here's where perhaps the greatest trouble with this dilemma comes in. One of the flight data system's main jobs is to basically keep Voyager 1's medical records up to date, then work with what's known as the telemetry modulation unit to tell ground control what's going on. But because the flight data system itself is the one malfunctioning, that medical record transmission can't happen. The engineers said the team has attempted various simple fixes, such as resetting the flight data system to the state it was in before the issue began. This week, the team will send more commands to the spacecraft to gather information about the status of the onboard systems. In the coming weeks, the team expects to start making more aggressive attempts to reset various systems that might influence the flight data system. As of now, the team believes one possible cause of the issue has to do with the FDS's memory being corrupted by some mechanism that leads its binary code to sprout unintelligible patterns. However, engineers are also considering the fact that it could be a physical hardware failure. After all, Voyager 1's mechanics have been toiling away for multiple decades. Something could have simply broken down, hardware or software-wise. The anomaly has caused engineers to study and learn about the spacecraft. Much knowledge that was forgotten because it wasn't needed for many years has been recovered. As a result, it takes time for the team to understand how a new command will affect the spacecraft's operations in order to avoid unintended consequences. In addition, commands from mission controllers on Earth take 22.5 hours to reach Voyager 1, which is exploring the outer regions of our solar system more than 15 billion miles from Earth. That means the engineering team has to wait 45 hours to get a response from Voyager 1 and determine whether a command had the intended outcome. Thus, this repair process could take several months. But in a bit of a silver lining, the scientists have confirmed that Voyager 1 is exhibiting what's known as a carrier tone, which runs along a wavelength that doesn't carry information, but rather acts as a heartbeat. At the very least, we know it is alive. That means the spacecraft appears to be healthy other than the current issue. So if we can fix this, Voyager 1 should be able to continue its science mission. But the Voyagers are already operating far, far beyond what anyone expected of them. We know the more time that goes by, the more issues are likely to arise. We'll keep them going as long as we can, but we know they won't last forever. The spacecraft had a more enduring problem: their power supplies. Its radioisotope thermoelectric generator systems provide power by converting heat from the radioactive decay of plutonium-238 into electricity. But after 46 years, the fuel is now generating 4 watts less per year. NASA had turned off any systems and instruments not involved in the interstellar mission, and in 2019, it started turning off heaters in some of the instruments that are still running. That added a couple of years to the spacecraft's lifespan. Nevertheless, the Voyager 1 probe might only have a few years, or perhaps a decade, left in it. Eventually, its dwindling power won't be sufficient to run its instruments. At that point, the Voyager, in the words of Linda Spilker, who is currently serving as the Voyager project scientist, will become our silent ambassadors. As the spacecraft hurtle at 35,000 miles per hour into the unknown with its powered-down machines, it will still carry humanity's message in a bottle. In the words of Jim Bell, a planetary scientist at Arizona State University, and the author of a book on the Voyager mission's 40th anniversary, the golden record, a piece of human civilization, a piece of technology with a 1970s stamp on it, is going to persevere. It's not degrading, it's going to last for billions of years. It's going to outlast the planet that it came from. That is mind-blowing kind of stuff. Bell speculates that it might not be aliens, but our own descendants, who ultimately spot the far-flung spacecraft. And to be honest, that is not a wishful thinking. One day in the far future, we're going to be the ones who go find it when it becomes easy to travel and be tourists and see the Voyagers. At that time, we'll be thinking, wasn't that one of the most amazing things we did as a species in the 20th century? After all, Voyager 1's mission highlights the boundless curiosity of the human spirit and our relentless pursuit of knowledge. As it continues its journey into the unknown, it carries with it a message of hope, a testament to the achievements of space exploration, and a reminder of our tiny place in the vast cosmos. The end of communication with Voyager 1 will mark the conclusion of a remarkable chapter in human history, but its legacy will endure, inspiring future generations to continue exploring the universe. While engineers are working to extend the life of Voyager 1, James Webb Space Telescope has just found neutron star mergers forge gold in the cosmos. According to scientists, the observations of an unusually long blast of high-energy radiation, known as a gamma-ray burst, or GRB, made using James Webb and Hubble, allowed us to see gold and heavy elements forged, which could help us better understand how these powerful neutron star merger events generate the only environments in the universe turbulent enough to create elements heavier than iron, such as silver and gold, which results in a flash of light called a kilonova. Gamma-ray bursts, which are the most powerful explosions of energy in the known universe, have been associated with neutron star mergers before. But this discovery is different. These phenomena can be divided into two groups. On one hand, there are the long gamma-ray bursts that last over 2 seconds, and on the other, short gamma-ray bursts that last less than 2 seconds. While neutron star mergers have been associated with short gamma-ray bursts, long gamma-ray bursts were believed to occur as the result of the collapse of massive stars and not from such collisions. The extremely bright and long burst, designated GRB2300307A and detected by devices on board NASA's Fermi mission in March 2023, lasted 200 seconds. This marked the second most energetic gamma-ray burst ever seen. It seemed to be associated with a kilonova, designated AT2017GFO, and a neutron star merger that happened some 8.3 million light-years away, breaking the usual gamma-ray burst convention and challenging theories of how these blasts of high-energy radiation are launched. Stars are like stellar furnaces that forge the elements in the periodic table, beginning with the nuclear fusion of hydrogen to helium in their cores and continuing with the fusion of helium to heavier elements like nitrogen, oxygen, and carbon. The most massive stars, around 7 to 8 times as massive as the Sun, can forge elements all the way up to iron in their hearts. Once a stellar core is filled with this element, fusion ceases. That also cuts off the outward energy line that had been supporting the star against its own gravity for millions, or sometimes billions, of years. The cores of these massive stars then collapse under this crushing gravity, blowing away their outer layers in supernova explosions. This collapse transforms the stellar core, crushing electrons and protons into a sea of flowing neutrons, particles found in atomic nuclei that very rarely exist freely. However, in this sea, the neutrons are prevented from squeezing close together by a quantum principle called neutron degeneracy pressure, which can be overcome with enough mass to create a black hole. But sometimes there isn't enough mass for a black hole to come into existence. Those dead stellar cores, without the mass to overcome degeneracy pressure, are left as 12-mile-wide bogies, with masses between 1 and 2 times that of the Sun. However, there is a way that neutron stars can contribute heavier elements than iron to the universe. Not all neutron stars exist alone. Some traverse the cosmos in neutron star binary systems, meaning they have another neutron star in its gravitational clutches. As these dead stars orbit each other, they set the fabric of space ringing with ripples called gravitational waves that gradually carry away angular momentum from the system. This causes neutron stars to spiral together, emitting gravitational waves faster as time passes and leaking more angular momentum in tandem. Ultimately, the two collide and merge. This collision creates a gamma-ray burst and sends out a spray of neutron-rich material that help create the heavier elements of the periodic table. Other atomic nuclei around these collisions grab the free neutrons via the rapid neutron capture process, or R process, and become briefly lived super-heavy elements called lanthanides. Those lanthanides then quickly decay into lighter elements. This decay causes the emission of radiation, light we see from Earth as a kilonova. Thus, tracking the evolution of kilonovas can help follow the creation of elements like gold and silver. Over the course of weeks to months, Yuhan Yang, research team leader and University of Rome postdoctoral astrophysicist, explained that kilonovas span a wide range of behaviors. These behaviors depend on the composition of the ejected material and the type of remnant formed at the center of the merger site. Observations of most kilonovas do not extend to such late times in their evolution, but AT2017 GFO was different. Unfortunately, however, the late-time observational data for AT2017 GFO, collected with the Spitzer Space Telescope, were limited. They only offered weak signals contaminated by the kilonova's host galaxy and presented inadequate coverage in different wavelengths of light. These constraints had hindered scientists aiming to understand better kilonovas and the processes that create them. However, in the case of AT-2017 GFO, however, the sensitivity and multicolor coverage of James Webb and Hubble observations allowed Yang and colleagues to observe the luminosity of this kilonova at late times. We tracked the evolution of the transient event associated with GRB2303U7A up to 2 months after the burst and captured the full blue to red evolution of this transient, which can be classified as a kilonova, Yang said. We discovered the recession of the photospheric radius at late times. The receding photospheric radius provides evidence for the recombination of heavy elements, such as lanthanides, occurring in the cooling process. Heavy R process elements are needed to produce the observed data. This confirmed that neutron-star mergers do forge elements heavier than gold, and even confirms that long gamma-ray bursts can come from neutron-star mergers. It hasn't solved the mystery of why this particular neutron-star merger launched such an unusually long gamma-ray burst. This event proves that a long-duration gamma-ray burst coming from compact binary mergers is not a fortuitous occurrence, Yang said, adding, "There are lots of questions to still answer about these events. What enlightening revelations can late-time observations of kilonovas offer on nucleosynthesis? We look forward to joint observations of long-duration gamma-ray bursts, kilonovas, and gravitational waves in the future, which will help unveil the mysteries about such outliers." A remarkable information: a lander is now circling the moon. The robotic Odysseus spacecraft, built by Houston company Intuitive Machines, arrived in lunar orbit on February 21st after acing a crucial maneuver. Intuitive Machines announced via X that Odysseus completed its scheduled 408-second main engine lunar orbit insertion burn and is currently in a 92 kilometers circular lunar orbit. After traveling over 1,000 kilometers, Odysseus is now closer to the moon than the end-to-end distance driving across Space City, Houston, Texas, the company added in another announced via X Today X post. Odysseus's time in lunar orbit will be brief. The lander will try to touch down near the moon's south pole on Thursday afternoon, no earlier than 5:30 p.m. Eastern Standard Time. Success would be historic. No private spacecraft has ever soft landed on the moon, and no American vehicle has done so since Apollo 17 in 1972. During its lunar approach, Odysseus notched another big milestone, snapping its first photo of the moon that we know of. Intuitive Machines shared that image via X as well. Odysseus, which is about the size of a British telephone booth, launched atop a SpaceX Falcon 9 rocket on February 15, carrying 12 payloads toward the moon. Half of them are NASA science instruments, which the agency put on board via its Commercial Lunar Payload Services program. This program aims to help NASA gather data that will advance the agency's Artemis program of crewed moon exploration by leveraging the capabilities of private American lunar landers. Artemis aims to establish a crewed base near the moon's south pole by the end of the 2020s. This region is thought to contain large amounts of water ice, which could be used for life support and be processed into rocket fuel to help refuel spacecraft on the go. Odysseus's mission, called IM-1, isn't the first commercial lunar payload services program effort to get off the ground. Last month, Astrobotic's Peregrine lunar lander took flight on the debut mission of United Launch, Alliance's Vulcan Centaur rocket. Peregrine suffered a serious fuel leak shortly after deploying from the rocket's upper stage, however, and Astrobotic ended up steering the probe into Earth's atmosphere on John 18. The other 6 payloads Odysseus is carrying on IM-1 belong to private customers, including Columbia Sportswear, which put some of its Omni-Heat Infinity insulative material aboard to give it a deep space test. Odysseus isn't the first private spacecraft to reach lunar orbit. For example, the Bereshit and Hakuto R landers, built by a private Israeli team, and the Tokyo-based company iSpace, respectively. Both successfully circled Earth's nearest neighbor. Both, however, crashed during their touchdown attempts, Bereshit in April 2019 and Hakuto R in April 2023. That's all the information that we have for you today. And don't forget to give us a thumbs up if you enjoyed today's episode, subscribe if you haven't already, and hit the bell so you never miss out on future episodes. And be sure to also tell us what you think about today's content. Everyone's support motivates us to continue delivering quality content and to always improve. As always, thanks for watching, and we will see you next time.